Okay, thanks everyone for coming in. This panel is Chasing Privacy in Blockchains. So what I'm going to do from my left is allow everyone to introduce themselves and the projects they're working on and how they're using privacy in the projects they're working on.
Good morning. I'm Mark Smith, the CEO and co-founder of Symbiont. For those of you who don't know who we are, Symbiont is a novel and purpose-built platform utilizing blockchain and smart contracts to address issues in financial markets. So as you can imagine, in a highly confidential and secure environment as financial markets, we utilize different types of privacy solutions in our platform in order to be able to allow our customers to remain compliant and protect confidential information.
Hello, my name is Zuko. I'm the CEO of the Zcash company, and we do both open cryptocurrency and enterprise blockchain. For the open cryptocurrency, we have deployed the software for an open cryptocurrency named Zcash last fall, and it's now a live open blockchain that anyone in the world can connect to and build on top of without permission. And on the enterprise side, we are applying the same technology to enterprise blockchains, and this morning we just announced our first enterprise customer, which is JP Morgan.
Congratulations on that.
Well done.
Hi, I'm Andrew Polstra. I'm a researcher at Blockstream doing research into privacy technologies for public blockchains. So over the last couple of years, I've worked on a lot of things related to hiding information while still making it verifiable that the information was created correctly. So a first example of this was confidential transactions, which is something Greg Maxwell, myself, Peter Willa, and a few others published, which allows the creation of Bitcoin transactions or Bitcoin-like transactions where all of the amounts are hidden, but the fact that the input amounts equals the output amounts is hidden. Or it's hidden, but you can still prove that everything adds up. So extending that, I've created a version of this which supports multiple assets, where you can see that every asset type adds up within the transaction, but you can no longer see which assets are what. Leading from that, I've been involved with a new research project called Mimblewimble, which is sort of a public, anonymously sourced technology designed to really hide the transaction graph information in a Bitcoin-like system. And then from there, this spawned yet another research project called Scriptless Scripts, which is my main focus lately, which is about creating basically smart contracts where the outcome of the smart contract is encoded in a digital signature, such that anybody can verify the contract was executed properly without knowing what the contract was or anything about it. So it's very fast to verify because there's no information to verify, but the people who make the transaction make sure that it could only have been made by proper execution.
Wow.
Great. Fantastic. There'll be a quiz after this to make sure you really understood what he said.
I'm going to fail that quiz.
Nice transition from super casual to an empty suit. My name is Prakash Santana. I co-lead the Deloitte blockchain cryptocurrency community, focusing on the risk aspects of blockchain. So a lot of people are trying to build prototypes and potentially implement in production. But what we are focusing on is to educate them on all the risk issues surrounding a blockchain implementation. Standard issues, what's unique about blockchain, what are the other things that they should be focused on, especially smart contracts related issues. So that's what we're here to talk about. I'm happy to be part of this panel in addressing privacy issues on blockchain.
Hello, I'm Ann Walwork. I am Senior Counselor for Strategic Policy in the U.S. Department of the Treasury's Office for Terrorist Financing and Financial Crimes. Our office is charged with identifying risks in the financial sector with respect to money laundering, terrorist financing, and the financing of the proliferation of weapons of mass destruction, and developing strategies to address those risks. We are a policy shop. We are not the regulator. And my particular focus is on new and emerging technologies, their benefits as well as their risks, and some people's privacy other people's anonymity. So we will be discussing those issues, I think, in this panel. When one's talking about risks of illicit acts in the financial sector, the issue of proper identification and verification, record keeping, transaction reporting where something is suspicious with respect to money laundering or terrorist financing is very much at the forefront of our concern as well as the regulators' concern. I must interrupt myself and say that everything I say reflects my personal views and does not necessarily reflect the views of the Department of the Treasury or its components. Thank you. And that goes for what I just said as well.
For all the lawyers in the room.
Yeah.
Thank you all. I'm George Semen, and I'll be moderating the panel. So we should probably just get into it since time is ticking down. So the whole point of this panel is that privacy has become a major issue, whether you're dealing with public blockchains or private blockchains that banks are implementing. Confidentiality is a thing, and that's one of the key architectural design concepts that everyone is employing on blockchains. So I'd like to start with a question to you, Prakash. What are the issues and challenges to privacy preservation on a blockchain?
Yeah, thanks, George.
And this could be answered by anyone else after he puts his answer in.
Good. So privacy is a double-edged sword, as Ann mentioned. More privacy you have, less anonymity, and there's going to be a conflict. But if you look at privacy itself, there are several aspects to privacy. The first one is, of course, transaction privacy. Unlike in the Bitcoin blockchain where everything is in the clear, how do you obfuscate data? Could you make that encrypted so people can't see what's in the ledger? That's the first part. The second part is metadata privacy. So if you know what law enforcement does today to track pseudonymous addresses on the Bitcoin blockchain, they use graph theoretic techniques and clustering analyses to identify groups of public addresses and then link them to an individual or an entity. So metadata privacy becomes extremely important, especially on a private chain, because if entities are forming together consortiums and are trading with each other, then metadata information will be used to track who's doing what and what's the flow going to a particular entity. So we need to make sure that privacy components guard even that aspect of it. So that's the second part. The third part is smart contracts privacy. So smart contracts, when they're executed, it executes on every node. So the key question is, how do you prevent parties from knowing what the inputs and the outputs going into a contract, and therefore using that data to figure out who's actually doing these transactions? So that's another aspect. The last aspect, which is related to privacy, I qualify that, but it is involved in privacy as well, is the right to forget. So as an example, if somebody changes their name and gender, and that information before they change their name and gender is on the blockchain, going forward, none of the contracts should be accessing that data, because that becomes a privacy issue. So there are lots of different aspects to privacy. Of course, there are tools being developed in the market today. For example, Zcash, to prevent using zero-knowledge proof, to prevent privacy tracking even and obfuscating even pseudonymous addresses. And Zuko is probably better positioned to explain that. And then, of course, Hawk. Hawk is another project that is involved in the privacy of smart contracts, again, using zero-knowledge proofs. So there are interesting developments. However, we have to see how this will be applied, because there are a lot of scalability issues to privacy as well. Simply because of the fact you have an algorithm, zero-knowledge proofs, the way they work, you have to show proof. You don't have to actually show the data associated with it. Zero-knowledge proof, a very simplistic example is, if there's a door and you know the secret passcode to enter the door, and every time I say left, you show up on the left side. Every time I say right, you show up on the right side. That means there's proof that you know the secret, right? So obviously, as a simple example, I'm simplifying this example. So obviously, there's work to be done to prove that you have the secret associated with it, and creating the proof obviously costs time. Sometimes it takes up to a minute. So when you start to throw in all these privacy protocols onto a blockchain, the throughput starts to drop dramatically. So there are scalability issues associated with it. Lastly, privacy is all, if you encrypt the data, obviously it's protected by your private key. So what happens if you lose that private key? What happens if it's stolen? There's still some unanswered questions in terms of how to address privacy. So let me stop there. And
Yeah,
return back.
Prakash, thanks. That leads right into my next question, and I'd like for Andrew and Zuko to answer this one. It's about that sweet spot of privacy and usability. Like, so if you make it too private, it becomes hard to use. It becomes not very scalable, right? So how do you, when you're designing it, think about that, and where do you really see the sweet spot between those two things?
What I think is the scalability is a technological problem that we're making pretty good progress on. The underlying mathematics behind Zcash is only about 3 or 4 years old, and that's a pretty short time frame to deploy a real product. And we and others already have many ideas about improved performance and efficiency and scalability. But the usability problem is not something that technologists can just make progress on in their math labs. That requires a different way to think about it, or integration with different layers of the system or something. So that's a bigger problem in my book.
Right. And how are you thinking about this?
I would pretty much agree with that. If you'd asked me this question 6 months ago, I would not have known how to do a lot of this zero knowledge kind of stuff as scalable as we know how to do it now, by an enormous factor, by like a factor of 1 million. The research happening here is just extremely fast for specific types of contracts, I should say. I can't do fully general zero knowledge proofs the way you are, but I can do some specific things almost as fast as producing ordinary signatures.
Yeah, so maybe you could talk about like confidential transactions and how you guys are now doing confidential assets and how you're thinking about that.
Right, so the way that confidential transactions works is that you replace every single amount with what's called a homomorphic commitment, which is, it's basically an elliptic curve point. You can add these curve points. I'm trying not to get too technical here. You can add them, you can see if they represent the number 0 or not. That's the only thing that you can really identify as the number 0. And that's, you can't even do that. We set up zeros that are very easy to identify. So you can add up all the outputs, subtract all the inputs, say, oh, that should be 0, and that's very cheap and very fast to check. And this is a very simple zero knowledge proof. All I'm doing is adding some values to see if they add to 0. But we can do that much, much faster than we could do more general things such as Zcash does. So most of my research is focused on doing very specific, narrow things, but that have wide applicability, and they give us a lot of benefit for how narrow they are technologically.
Right. Thanks.
Let me add something else about usability from what Prakash said, that there's a big problem with using secrets as the way you control access to things. I agree that's a big problem, and it's one that Bitcoin has been having ever since it came out, and it's not well solved yet. I'm hopeful that the Bitcoin community or in the Ethereum community will make progress on tools or practices or services or something to allow people to control their secrets reliably and usably.
Right.
And from a practical standpoint, at Symbiont, we take a little different approach. So first of all, we owe a debt of gratitude to the team at Blockstream because we use confidential transactions as part of our privacy solution, as well as asymmetric and symmetric cryptography for secure channels. We look at it from a practical standpoint, and how do you deploy and use what's known in the marketplace today, best practices, and keep up with all the new cutting edge things that are happening and watching them evolve. So congratulations again for JP Morgan. That's a great case for us to look at and say, that's a constituent type of customer that we would like to see, is that a solution we could use in the future? But you make the choice to go into use cases that don't require high speed, that are already somewhat opaque. And for example, in syndicated loans is the big place we've utilized that in a production environment. Syndicated loans take 19 days to clear. It doesn't matter if it takes a second or two to move through the process of delivering the payload with cryptography in order to ensure that you're getting the privacy you need for your constituents. So we sort of allow for plenty of time for scale to happen. You don't optimize off the bat. You get a secure solution. You focus on that security and privacy as the main component. Solve that perfectly. And then over time, you think about, how does this scale? How do we optimize?
Right.
And then you can think down the road, okay, now new applications for this because we can now optimize to that use case.
Thank you. So Anne, I want to talk about the regulatory issues with privacy. So how can you have a complete privacy, maybe anonymity, and allow for regulatory purview? Or in your opinion, are those things not at all the same and they need to be fixed?
Well, I think they're almost currently siloed areas of privacy versus anti-money laundering, counter-terrorist financing controls. And so there are privacy requirements that apply to financial institutions that are different than the AML-CFT controls. I am not a privacy expert. So I would like to just address the regulatory structure that impacts financial institutions that are conducting transactions using, for instance, cryptocurrencies in the financial space. So with that said, responsible financial innovation, innovation that meets consumer needs, that complies with relevant regulatory requirements and objectives, including anti-money laundering, counter-terrorist financing, cybersecurity, and privacy, that can foster competition and also financial inclusion, is really important and is to be supported. But, and here goes the answer to your question, in the financial sector, there are rules of the road. And one of the most fundamental of them, both in the United States under the Bank Secrecy Act and globally under the recommendations established by the Financial Action Task Force, is that anonymous business relationships between financial institutions and their customers on account-based ongoing relationships are prohibited, and that occasional transactions, i.e. transactions for persons or businesses that are not ongoing customers, are risky and need to be regulated appropriately above given thresholds. So either now or later in our conversation, I can go really briefly into what those requirements are.
Yeah, I mean, one thing that I want to follow through with you on is, so would you say that the government is fully aware of these anonymous currencies and attempting to figure out what to do with them? Is there some kind of plan and action? What's the stance right now on it? Is it too new? Obviously, they're tracking it and looking at it. No, it's not too new. Okay. What I would say is that the new products and services have come into an existing, highly regulated ecosystem, the regulated financial sector. So yes, government is very aware of both the technology and some of the use cases. The technology itself, and I think this is really important, and Zuko will agree with me, government doesn't regulate technology. Good regulation is technology neutral. It also, in the financial sector, with the exception of prohibitions on sanctions on terrorist financing, there's a list established partly under the UN and then partly under national legal frameworks of individuals and entities with whom it is prohibited to engage in financial transactions. That applies to everyone under, say, US jurisdiction or under EU jurisdiction. But that aside, the money laundering, terrorist financing regulations apply to financial institutions. So when we're talking about virtual currency, we're talking about financial institutions engaged in virtual currency financial transactions, payments essentially, not blockchain technology that may provide the rails for whatever types of financial activities the financial institutions are engaged in. So under the international requirements established by the Financial Action Task Force as the standard-setting body for anti-money laundering, counter-terrorist financing,
financial institutions are prohibited from having anonymous accounts and must identify, and this would apply to, say, convertible virtual currency exchangers or hosted wallets. They must identify their customers at a zero threshold if it's an account-based relationship, an ongoing relationship, or for cross-border at greater than 1,000 for occasional transactions that are wire transactions. And in the virtual currency space, pretty much every transaction would qualify as a wire transaction because it's defined as, that wasn't peer-to-peer. It's defined as a transaction that is originated at a financial institution with the idea of providing value at another financial institution, the beneficiary financial institution, for a beneficiary, and that beneficiary can be either the originator or another person. So basically any flow of funds in the virtual currency space between financial institutions would be regulated. That said, peer-to-peer transactions are not currently regulated, and user transactions, where you use the virtual currency for purchases or investment purposes, are not regulated.
I'm going to, okay.
Could I add a few points here? So there are a couple of things in the regulatory aspect. So the regulators are primarily focusing on, as Anne mentioned, on money laundering and terrorist financing as it relates to all payment transactions. Nothing specific to blockchain.
Right.
So any technology that implements a payment rail will immediately fall under this purview. However, blockchain-specific regulatory issues are only starting to evolve. As I mentioned earlier, right to forget, because blockchain is a ledger that stores transaction for posterity. So the exercising or enforcing smart contracts to not look at past transactions. It's an important area that's going to evolve. The second part is the network itself. How many participants are cross-border? Is there any transaction that's potentially cross-border? Let's say one node sits in Germany. The privacy requirements there are very stringent. Does that apply even to hash transactions? We don't know. So these are things that are still evolving. So that area of focusing on all blockchain-specific regulatory issues are still evolving. We don't know the answers to many of those questions.
Right. So I'd like to open it up to you guys and talk about why you think anonymous currencies are necessary, what your thoughts on what they're talking about, and the fact that there's more than there's not just Zcash, there's other anonymous cryptocurrencies out there, right? Is there a need for more than one? If one works really well, why do you need a couple of different types of privacy schemes?
That was a few different questions.
Yeah.
Yeah, sorry. So I just feel free to answer them.
Okay, so one reason that we want multiple ones right now is that, as Zuko mentioned and I did, the research and technology here is advancing very quickly, often in different directions that perhaps will eventually converge, maybe they won't. But right now we're really in a phase where we're exploring different ideas. We're exploring different privacy models. So like the model that confidential transactions gives you is one where nobody can see the amounts, but they can still see how the transactions are put together. What Zcash does is a system where you can no longer see anything. You see that some coins existed and then they were spent. There's another currency out there called Monero, which does a partial obfuscation of the transaction graph as well as transaction amounts, which gets closer to Zcash than confidential transactions does, and it's a bit more efficient to produce and verify the proofs here. And all of these are taking sort of different directions. Oh, and a fourth one is my own scriptless scripts here, where we're just trying to produce transactions that don't really ever touch the blockchain except as a final signature that's used as a verification token, more or less. So all these different research directions are happening very quickly, and they're more or less separate, and that's the reason that we see multiple systems today.
Sure. You asked what's the use or something of private?
Well, just from your vantage point or viewpoint, the philosophy behind why you wanted to make Zcash.
Okay. We started the Zcash project at a time when Bitcoin was almost the only real cryptocurrency. And there were others, but Bitcoin was the only important one. And it seemed to me that Bitcoin was a dramatic departure from the traditional management of privacy and security in our society, and that we should be able to do better. The uses of privacy in payment systems include business primarily. We found out right away when we started the Zcash project that we get a lot of positive feedback from private individuals who just say, privacy is important to me, privacy is part of my life, it's part of my family, it's part of my political activities, and at the same time we got even more positive feedback from businesses who said, we want to use cryptocurrencies, we want to use blockchain, but we can't until it has this kind of data security.
Got it. And Mark, maybe you could tell us about some of the use cases that you're looking at from a privacy perspective, how you're using the confidential transactions and what for?
Sure. It's actually kind of enlightening sitting up here because day to day you think, wow, we've chosen such a difficult path. Institutions, highly regulated, we have to deal with, but we don't have to deal with anonymity. And I think that gives us a little bit of leeway versus how stringent the anonymity problem is in a permissionless environment. All of our deployments are permissioned environments, so we operate isolated networks for specific use cases and a general network for to propagate different types of smart contracts that may call one another from different use cases. But in every case, the operators of the network are responsible for all the traditional AML, KYC regulatory pieces, and there's always an account off the ledger that is connected to the pseudonym on the ledger. So we're really talking about pseudonymous transactions from our world and not anonymous transactions. And then we can borrow from and learn from the harder use cases, which are going on right now here, and then utilize those different solutions. So, for example, we use confidential transactions exactly as defined from Blockstream, where we have multiple counterparties entering into a transaction with one another, and each of them needs to know certain pieces of those transactions, but not all the data is shared amongst each of them. So we use confidential transactions to obfuscate that information, but still allow for a chain of custody to exist, for the log or the ledger layer to be able to attest to the provenance and allow for each of the nodes to properly execute the terms of that particular smart security or smart instrument that's happening. So we're doing it now in syndicated loans, as we pointed out. We're doing it in private equity, where you are creating new corporations, and those corporations need to be able to share data about transactions with certain investors and not others, but also to be able to allow for regulators to sit on these different networks and do real-time surveillance. And we're talking about now proactive regulation. So the idea of taking algorithms that sit on top of the ledger and consume the data and look for patterns that could be troubling. Those patterns present themselves through the chain of custody without actually having to know the details of the transaction. And then a regulator can reach out and say, hey, this block of transactions, I'm interested in drilling into them. What's the identity, or how do I find out the identity of these 4 actors? And then we can say, go to this bank or go to this government who is running this network, and they can connect that pseudonym to that account that's been set up and gone through the traditional AML KYC, and then go through dispute resolution as you would, except for with much better data, because you can now have the cryptographic key to then unlock all the secrets and see the data live as a regulator.
Can I just respond with a couple of points? And that is, you mentioned like government surveillance as if it were the government's responsibility to identify the suspicious transactions. Whereas in point of fact, under the current regulatory structure, the obligation lies on the financial institutions to conduct monitoring of transactions and identify the suspicious ones and report those. There are reporting obligations as well. But I do think you point to one of the potential benefits of distributed ledger technology and big data, assuming that the countervailing privacy constraints don't prevent the visibility into that by financial institutions, and that is that it, and speaking personally, it can very much be moving us into a new generation of RegTech, where it's not just supporting the compliance functions of financial institutions, but also changing the way potentially regulators can conduct their own supervision and examination. So I think there's a lot of promise there. I would be remiss if, when we're talking about privacy as one objective, I didn't, sitting where I sit, say that the prohibition on anonymity and the information that's required for transactions above a given threshold serves very important values I think we all hopefully would agree with, including those individuals who, and privacy advocates for whom privacy is really a critical value. And the other values are protecting the global financial system from abuse and preventing cyber criminals who right now with WannaCry, the currency that was requested for the ransomware payments was Bitcoin. It wasn't a fiat currency, and it points to the need for global regulation. But it's not just, and for cyber criminals, Bitcoin is the currency of choice. The same is true for other illicit actors who are selling, things like, if I could just continue, things like child pornography, et cetera, on the dark market. So
Right.
I think that the idea behind these regulatory requirements is to prevent bad actors from abusing the financial system, including new technologies, but also to enable law enforcement to investigate and track.
Right. But we talk a lot about the financial system, but there's probably a lot of other use cases that people are looking at for this technology. Maybe ZK Snarks can be used outside of financial services and any other technology out there. But can you comment on that and talk about if you're seeing any use cases that are evolving that are not financial services based?
ZK Snarks are a really general purpose kind of math, and Zcash is just the first use of it. But I'll just give an example of the weird kind of things that you can do with this math. You can use ZK Snarks to prove that a certain image is a cropped or brightened version of an original image, but that no fake stuff has been photoshopped into it. That's the mathematicians keep coming up with these mind-blowing
Maybe you
new
can
things.
start to combat
I don't know-
fake news.
I don't know where it stops.
Yeah, that's exciting.
Hey, I have a question. You two both seem to differentiate between privacy and anonymity, and I wonder what you meant by that. Like, what is the difference between privacy and anonymity to you?
Well, anonymity to me means that you do not know who the real world biological person or legal entity is. Privacy involves, and here I'm not an expert at all, but it is that you have control over who has visibility into your activities, and that there's a difference between identity and privacy.
I think that's a good definition.
Yeah, I tend to agree. And we even look at anonymity as a very stringent and rigid case to say this is anonymous and this will remain anonymous unless you find a way to breach it. Privacy, you can invite people in to see information if you so choose. So in our world, there's no need for anonymity, but there's a lot of need for privacy and confidentiality of the business we're transacting with one another for many reasons. In financial markets, it's as simple as I've got a trading strategy I don't want someone else to figure out, and so I don't want them to see the data. And others where there are regulatory outlines from the Security Act of 33 or 34 that say these things have to be handled in a certain way, and therefore you need some level of privacy. So we separate those two things out. And it's, for us, again, the other interesting part is a lot of this is focused on the concept of currency or a payment. So you have money transmission issues and money moving around unfettered. We look at it from the instrument standpoint, not the payment standpoint. So when we create a smart contract, it represents an instrument, and in that instrument, we can not only automate the terms and conditions like most people talk about with smart contracts, but we can also have the negative effect to restrict behavior through RegTech. So if you can't transact something for a year, the smart contract has that as part of the component, and if you attempt to transact it, it will restrict it from that transaction before 365 days are up. Again, which alleviates some of the burden for us because a lot of the focus is on the payment side of the house, the currency and what's happening, and all those other rules and regulations flow off of that. We're not rooted in crypto economics, and therefore we don't have to concern ourselves with that. We bolt on payment solutions that are mostly traditional until some of these new and exciting cryptographically based payment solutions become ubiquitous, and then we can plug those in to the platform and know that it'll be compliant.
Could I add to that?
I think we need to start wrapping it up a bit because time,
Because it says so.
because it says so right there, and because
In
time
red.
is very close to ending. So I just want to ask one final question to Andrew. Any trends that you're seeing in the privacy space that you want to talk about that you think will continue, or stuff that hasn't come online yet that will be there at some point?
Yes, there are things that will come online soon that no one's seen before.
Hey, excellent.
So yeah, what we are seeing on the research side of things, there's a lot of progress towards much more efficient things and much more private things than have existed before. And we're also going to see a trend towards these systems being out there and being implemented in the real world and being able to be used by anybody. There's nobody gatekeeping. There's nobody who has the keys to harm anyone's privacy. There's also nobody who's a gatekeeper to control people entering and leaving the system. And I want to quickly address Anne's comment about criminals using Bitcoin.
Sure, you have
Criminals-
18 seconds.
I know, I have 18 seconds. Okay. The reason Bitcoin is used online is because it's very cheap and quick to transfer online. It's not used for anonymity. If you're in a criminal industries are very high margin industries, you can afford to anonymously transact. And you do this by laundering money, which is a very, I don't want to go into too much detail about how to do this. It's very expensive, and it's much easier to do with cash than with Bitcoin because Bitcoin is online. And I worry, okay, I'm being cut off, but I worry about harming privacy on the transaction layer in a system where anybody can come and go, because you can always layer auditability on top of a system that is private. You cannot layer privacy on top of a system that's inherently non-private.
Thank you. Awesome panel. Thanks a lot, guys. Appreciate it.